Hello, and welcome back to the Inside Java podcast, a podcast about everything Java, brought to you from the team at Oracle who makes Java. My name is Anna Maria Mihalceanu. I'm a developer advocate in the Java Platform Group, and while at DevOps Belgium 2024, I catched up with Per Minborg on fields immutability. Per Minborg works in the Java Core Library team at Oracle, is member of the Panama project team, and co-author of the publication Modern Java. But he also is a regular speaker at events, so you probably know him from the performance and foreign function and memory API talks. So, Per and I had a conversation on performant immutable value holders, what they are, why do we need them, best practices, and many more. Without further ado, let's get right to it. Per, welcome.
Thank you.
First time being a guest on the Inside Java podcast. Well, can you please tell us more about yourself to our audience?
Yeah, sure thing. So I actually started off with Java 1.0 way back in the times. So I'm an old guy. And then I started to work with some open source third-party libraries around Java around 2000, a little bit after 2005 maybe. And so I've been doing that for like 15 years. And then I started to work for Oracle, which is great because I think that, I've done a lot of Java, and I think there's still, while Java is a very good language as it is, there are still things to do. So here I am.
I'm glad to have you here. Well, I've been looking into some interesting things that you were working on, and the names table values draw my attention. So can you please tell me and the audience, what are stable values? What's the story behind them?
Yeah, so Maurizio and I have been working with this concept for a very long time now, more than 1 year. And we started off by thinking that, why don't we bring laziness to Java? But as things usually are, when you start to think about it, the more you think about it, the more you realize that this is not really the primitive thing. The primitive thing is not laziness. The primitive thing turned out to be something called deferred immutability. Because today, we have had, even since Java 1.0, final fields, which are immutable. And then we have like mutable fields, non-final fields, which are unsurprisingly mutable. And you can change them as many times as you want. But there is this tension between them, so you have to pick one. You have to choose one, lose one. And when we start to think about it, I think we did maybe more than 10 different prototypes, and they grew larger and larger. And once we arrived at this conclusion that we want to model this deferred immutability instead, everything shrank. And so now we have mutable values, which is a combination of mutable and immutable fields. You can pretty much pick the best of two worlds there.
Wow, it sounds really, really cool. So if I'm just to ask for a sneak peek, what does table value API offer us in terms like, interface?
Mm-hmm. So once we have went through all these 10 prototypes, we think now that we can model stable values with just a single interface class, with just 5 methods and 5 static, factories. So it's a very small API, and I think that's encouraging because now it has kind of collapsed into something much more dense. The complexity is reduced, and we are really offering just the bare minimum of what we need to offer. And the thing is, you might think that, wow, I can write a lazy class myself. And yes, you can, but it's not a stable value. Because you need to have things not only in the Java side, but on the VM side as well. There are some, there's a magic sauce in the VM itself. So it's able to treat stable values in a special way that we might talk about a little bit later. So I won't spoil that for now.
Okay. Okay, but now we're talking about picking the best of the two worlds. But I must ask, is this new API meant to prevent or deprecate idioms from expressing lazy initialization?
Mm-hmm. No, not really. So you can still do the old sucky things that you did in the past. You can still use double check locking idiom. You can still use the class initialization and rely on that. But that gives you some disadvantages. For example, if you have a double-checked locking idiom guarding one of your mutable or deferred immutability, the VM is not able to optimize that because it can't see through. It's not able to reason about deferred immutability. This double-checked locking relies on a mutable field, and so the VM cannot rely on that value being stable, and so it cannot, for example, do constant folding on it.
Yeah, because when you're referring to constant folding, just for a kind reminder for our listeners, you probably know that the Java compiler gives you four great stuff out of the box without any other flag, and constant folding is one of them. So what this improvement of stable value brings to us is to benefit of something out of the box with compiler with a constant folding. So
Yes.
we're actually taking advantage of something that the Java compiler has in it.
Yeah.
And we're taking it for free, no flag, no extra tuning for performance. So
So maybe now is a good time to explore a little bit about the inner workings of stable value.
yes, well,
Or is it too early?
no, it's not too early. It's just that I'm thinking that, well, stable value is also an API that's meant to improve performance. So let's discuss a few examples that would benefit the stable of values, and maybe start with one that we do it so much automatically in our code. And let's face it, I've done it so many times, and at some point as a developer, I'm not even wondering why I'm doing it like that. So it becomes like something automatic that we do, and we're not thinking of the consequences anymore. I'm talking about the trivial case of the private static final logger instantiation, which probably all of us are doing like blindly in our classes, and we're thinking like, we're doing it. It's a small thing, doesn't have any impact, right? But
Yeah,
it's
sometimes.
not that small, huh?
No,
Tell me
sometimes
more.
you wonder if that should be, a special feature of the IDE just to support add a logger for me. But the thing is that, initializing a logger entails a lot of work. So when you reference a logger, there is usually a configuration file that you need to inspect. Where is my logger file going? What's the format of logging it, and so on. And maybe you have even to prepare a storage space for it. Maybe you set up a special directory with log rotation and whatever for this, or some people even store stuff in databases. And that takes a long time. And now assume that you have 10 different managers, or whatever we call them, or like you have an order manager, for example, which has a logger, and then they have a user manager, which are different managers. And they all have to create this logger upfront as soon as you reference them. The VM goes along and loads the class, and it needs to reach out, parse the XML file, create some directories, and do a lot of other stuff. So your startup performance is really hurt with this. So that is one thing that we think that stable values can solve for us.
Yeah, well, I remember the times when we spent times in fine-tuning how we are logging things, where do we log things, how we rotate the logs, how often we rotate the logs.
Yeah.
And also like trimming what we log and other stuff. So while it seemed simple and we see just one line there, that line actually hides a lot of work for us, the developers. So I'm happy to hear that.
So maybe I can tell you how you should write it now that we have stable
Tell
values.
me, I'm listening.
So instead of having a static final logger, you have a static final stable value of logger.
Okay.
And then you say, I want to create an empty slot of this. Here is a place where you can store a logger. And here is the recipe, how I want to create my logger. And you just declare the field and the logic, they usually lambda upfront. And then you forget about it. And then you can just access that field. And it's just when you access it the first time, maybe in another thread, maybe a minute later, and it will call this lambda and store this value. And this is guaranteed to happen exactly just once.
Oh, wow.
So, and that's the reason, that's the key of deferred immutability, and that's the difference between laziness, because laziness in itself doesn't imply that you can only update the value once. I mean, you can do it lazy and then you can update the value again. But deferred immutability says that there are exactly two outcomes. You can update it or you can update it one time, but nothing else, even in a multi-threaded environment.
That's a very nice and very nice thing. When you were talking, I was just thinking the many times in the projects that my past Spring Boot, Quarkus, and other projects where I've been doing services, and other parts where I was just doing the logger instantiation, and I was thinking, like, yeah, probably that was costly at some point. And
Yes.
now it's going to be also an elegant way to deal with let's say lazy initialization, deferred initialization.
Yeah.
It's not just an enhancement done to be there. It's also an elegant way through the API that we can do that.
Yeah, and the story doesn't end there because not only the loggers in the components can be, stable, but also the components themselves in the application. So I can say that, oh, I want all these 10, managers, but don't create them now. Create them later when I need them. And so the startup performance will increase even further because now you have this kind of transitive way that this order manager is only created when you need it, and then the logger is created the first time you need that. And everything just works with mechanical sympathy with the VM. So you will still have this performance as you would have declared them up front, but you will have the startup benefits of declaring them lazy. And maybe you are not using some of the managers at all because they are, rare in use or just corner cases. And the same thing goes for loggers, and those loggers, they don't have to be initialized up front.
So while you were saying that, I was thinking to a project that I've been working recently, but I haven't disclosed yet. So I'm working on making my own Pac-Man. Is with JavaFX. I'm thinking of different ways of doing Pac-Man, but not just with JavaFX. And in my JavaFX implementation, I have a couple of places where I use singleton. And while you were talking, I was thinking, like, yeah, but some of the managers that I have in the game, like the way I thought about the game, I don't need them until I reach a certain level in the game. It would be good not to have them all at once, like to have a better management of them, because right now I'm just doing that through ifs and
I see. A switch rake.
yeah, and
Yeah.
it's not elegant. I mean, while I was coding, I was looking at that and I was thinking, maybe I can do it better. I mean, I felt this need, like, it should be a better way. It's always with us, all of us, I think, when we're coding, you're always thinking, like, I think this could be cleaner, it could be better. And I think it's one of the curses. The more you become, the more you know stuff, probably it comes with, like, oh, maybe that would be a better way, and you're never satisfied with what you're
Yeah.
doing.
I mean, that's good. That's constant strife of getting things better and better. That's what drives us to improve Java and, our applications and in our average daily life. So that's a good thing. But as you mentioned it, there are a few idioms that can really, benefit from stable values. You mentioned singletons, which is a primary case of stable value usage, because you can just say that, well, here's my singleton and here's how to produce it, but don't do it now. Only do it when you need it. And then I'm guaranteed that there will only be one copy of that singleton, even in a multi-threaded environment. So that's great. And when you reference that singleton, it will be equally fast as you had declared it up front. And usually, if you have several singletons, you have this kind of, intertwined way of initializing things. If you have it in a static classes or a static initializer, you depend on the textual order in the code, or
That's what I have for my Pac-Man, actually. I have several singletons, and it kind of bothers me.
and it's kind of entanglement of everything. It's like a hairball. And why not just say that, well, here's your singleton X and here's your singleton Y, and here are the recipes, and just create them when you need them.
So when I was working on one of the variants of the game, I was thinking, like, maybe I became too obsessed with singletons. What is going on with me? Because I'm worried, like, sometimes when I see myself using too much of a pattern, I'm thinking, like, maybe this became too an automatism for me, and I'm depending too much on this and repeating myself too much. And I don't want to get into that routine of using one single pattern too much. It kind of drags me into the, maybe I'm missing something. And I hate the routine part, especially when coding. I'm trying to find better ways and not just stick to the basic things. That's why sometimes things turn to be complicated.
Mm.
But we love complicated as developers as
Yeah, and you feel proud. Oh, I mastered this complexity. Hooray, I'm a hero.
yeah.
But wouldn't it be better to say, wow, I managed this complexity by reducing complexity? I think that is better than actually, wrestling with complexity. Being able to break it up, being able to compose is a much better approach.
Yeah, that's something that I admire of yourself, of Maurizio, and other folks in working on Java. That you tend to listen a lot for the feedback. That something that maybe is complex at the beginning is thought so many times, and is turned into something so much more digestible by everyone. And that's the beauty of, again, collaboration and
Yeah. I think that, while that sounds good, it's also very frustrating because we want to ship things.
yeah.
As Brian just mentioned, we have this peak of complexity, and you shouldn't, ship on the peak of complexity. But you get frustrated when you get, well, someone say this, someone say that, and you have to rethink again, and you do this 10 times, and you get kind of, frustrated and question your own ability and so on.
Yeah.
But I think it's about you have to hang in there. You have to understand. You have to give it time. It's not like the Java, language or Java core network libraries are, just an application like anyone else. This is something that's been used by millions of developers.
Yes, but even in the case of applications, and this is the story of the application developer and person and technical lead and so on. Even on that side, the more you get as experience, the more is expected from you and teams to build evolvable architectures. And building evolvable architectures with the patterns that we have right now, which are awesome, by the way, it always, as a developer and architect and so on, you have to strive for a balance of what you're implementing today. It has to be evolvable tomorrow, the day after tomorrow, when the needs for your application might change depending, like, I don't know, your user base becomes larger.
Yeah.
You need to deploy in different geographies with different constraints. You need to maybe adapt certain services to things, and you want to be able to change those with less struggle. Because let's face it, rewriting things, it's expensive in terms of time of development, and it can be also a daunting activity to like rewrite things all the time.
I think of it like when you are evolving Java as such.
Yeah.
It's like having the command of a super tanker, because you cannot just turn direction on a quarter. You have to be aware of not only the situation within your vision, but you have to envision what lies behind the horizon. Well, is there an iceberg there? What should I do? And so you have to, when we did Stable Value, we thought about what's coming out in Valhalla, how does pattern matching evolve, and other things, because we need them to click together like Legos in the future. We don't want to come up with something and then 5 releases later discover that, oh, we didn't thought about that.
So this means that stable values are having an impact on things in the JDK as well, or maybe can share more about you think of using it in some tools.
Yeah, I think so. I think there are many places where we can use stable value internally. So for example, Swing is kind of an old code base. And then we have like singletons are guarded by synchronization and other things. What if we can just replace them with stable values? It will start up so much faster, and lazy initialization. We have JExtract, which I heard your talk about just the other day, which was great. And there we generate bindings for native methods. And all the bindings are eager. So you might have maybe extracting standard lib from C, and then you have hundreds of method calls. You have printf, socket, close, fopen, and all usual suspects. And when you reference that class, hundreds of bindings are being done.
Okay.
So that will impair your startup time. But what we can do then is that we can use a special feature that is available for stable value. So we don't only have a single stable value, but we have collections of stable values. And So we have, for example, a stable list and a stable map. And in this example, I think pretty much a stable map is the way to go. So you say that you have a map with the key of all these, printf, socket, and fopen and all that stuff. And then you have the recipe for creating them. And it's only when you are referencing them that they are being created. So imagine that you extract this huge library, but you only use maybe 3 or 4 functions. And it's only those 4 bindings that will ever be materialized. And all the other are just lazy, waiting there to be called. So I think that's a good thing. And this brings me to another thing with maps. I just keep on talking here.
That's okay. It's okay. It's okay. I love listening to you.
Yeah, so you can say that then if you cache stuff, that's a very common thing in applications, that you have a non-evictable cache. Non-evictable means that once you enter stuff, it stays there forever, or at least virtually forever. And that's something that stable value is perfect for. So you can just say that here are my values, my keys, and here's how to create them. And then we'll enter them lazily into the map. And when you reference them, they will be constant folded. So they will be equally fast as you have just, enter that code inline in your application. So that's pure magic.
Wow. Oh, it's not exactly magic. It's done simpler.
Yeah, it's done simpler.
When you were talking earlier, I was thinking that the two things that are so tough for us as developers, naming things and working with caches, and they really are. So working with caches is a great thing. So this means that the stable values, they work great with collections as well. So it's not just something that works with certain types like loggers, like it's not just for trivial cases.
Yeah.
It also works with collections of objects. We can do advanced use cases for it, like in the case of the evicting caches. So that's pretty impressive about this feature of it. I'm gonna get into this because you mentioned like magic. Is that a secret sauce that has been added to this?
Yes, so it's not actually magic. It's pure logic, of course. I was just exaggerating a bit, creating this aura of coolness, hopefully. But stable value relies on 2 things, actually, which is the secret sauce. So the first thing is an internal annotation that's called stable. And we use this heavily within the internal JDK class, and it can only be used in the internal JDK classes. In fact, it can only be used by the first bootloader, the root bootloader that you start. Otherwise, it's ignored. And that is that we have to guard these stable values very carefully. So if you update a value, it's imperative that that value is not updated again. And that's what stable value does, actually. So it has an underlying data object, which is, a field which is annotated with this internal annotation, which is called stable. And so we guard it very carefully. We'll compare and set operations, and that guarantees that the value is only set once, even by multi-threading. And then there is another, component of the secret sauce, meaning that fields that are declared as stable values, they got a special VIP treatment within the VM. So they are trusted, just like fields in records. So when we created records many releases ago, we added kind of a harness around it that made it very difficult to change the values. And because the values are very difficult to change, the VM can trust that the value, they don't change. And we made the same promises for stable values. So if you declare an instance variable as stable value, it has a certain meaning. It means that the VM can trust that this will never update. And it's, extremely difficult to update it. So that is the other part of the secret source. And this is not something a regular Java developer can do. You have to have access to the inner workings of the VM.
Yeah, and I mean, we all can see the code in OpenJDK, but the thing is that it's for our own protection that we don't have access to everything, and
Yes.
because we tend sometimes to overuse. I mean, and to like, if they've done it or if there are ways to access
Yeah.
that, why not?
Yeah,
Let's force
exactly.
the access.
Yeah.
I mean, it comes with the way that our mind as developers work. We want to find the solution no matter the means sometimes.
Yeah, I've been there too.
So it's better to use a trusted solution, a trusted API. So that's why most of the time with OpenJDK we get APIs that for us to use safely and to benefit of safeness and integrity in our code, not just making code and hope it's gonna be
it might
good.
work. Yeah. Also, you can say that stable value is a safe wrapper around the internal stable annotation, and hence the name.
Gonna say yeah. Okay, so I think that we'll go with the last question that I have for you. So you and the other folks, you and Maurizio and the other folks internally are actively working on advancing the stable values API to a concrete state so that all of us can just take a look at it and try it. But what alternatives did you consider, or are you still considering when working on this API?
So stable value had several names in the past in the various prototypes we have. It was called lazy at one time. It was called lazy value. It was called computed constant, and so on. But as we kind of converged into this minimalistic approach, I think the name stable value actually sat very good together with us. I think we will stick to that. And we are also working on a JEP. So we need a JEP before we introduce this into the language. It will be a preview feature, of course. So we have time to accumulate feedback from the community. And we want you as a listener, of course, to try this out. And here I'm excited to hearing about your reaction. How can you use this? Are you missing something? Is this good? Is this bad? That will be very exciting.
Yeah, there's a mailing list that probably, or maybe directly on the mailing list, people can reach out to you.
Yes.
And Maurizio to give some feedback on the existing work that is there.
Yeah, exactly.
But it sounds amazing. I mean, I'm excited about this. And I think that, I loved our conversation, and it put my mind into thinking to so many other aspects that I can do better when I'm coding. And that would help also my application. Sometimes when coding, we are so used with using certain constructs that we tend, and we know that Java is performant. We know that it gives us security, we get performance out of it, and with it release, probably something is done there under the hood for making it better. But it is good to be reminded on the impact of what those tiny things can have, but also on the impact that we can have, like in the case of the caches, on the bigger things or singletons.
Yeah.
So I'm really, really looking forward to seeing stable values for a spin.
Yeah. Kicking the tires.
Yes, so I'm looking forward to seeing it there. Well, in the meantime, dear listeners, if you want to get familiar with performance topics or foreign function and memory API, I recommend looking at Per as an author on inside.java. Check out his personal blog, because sometimes on inside.java we're referencing to his personal blog where he's keen on performance. So we love to publish his work on performance. Or watch his presentations. He's a great speaker, has been speaking to many conferences in Europe this year. So please look at those talks. They're not exactly the same content, because Java evolves, performance evolves. So he's keeping that up to date. Thank you, Per.
Yeah.
And remember, keep up with the latest news in Java. Make sure to subscribe to our Java YouTube channel and check out inside.java, dev.java for tutorials. We're going to keep you updated with what's going on in Java, what's cool to use, but not just cool to use, what's great to use for your code base. Thank you, Per, once again.
Yeah, and thanks for having me. Great to be here.
And thank you, folks, for listening to us. Stay tuned for more.